Well, we're at section 3. Now we're going to talk about measuring weight and temperature. Here are some of the things we're going to do. You can pause it here if you like and take a look at those, and we'll go through all those one by one. First of all, weight. It's the measure of gravitational pull. If the Earth didn't weigh anything, if the Earth didn't have any mass, there would be no gravitational pull and would float right off. Mass is a little bit different. However, good news is we're going to treat mass and weight as equivalent. They are very close, but just for example, if you have a mass, let's say we've got a mass of 100 kilograms. It's going to have a certain weight, and we'll just say this is test. If we go to the moon, that weight is going to be different. Smaller to be exact. It depends on how much mass the moon has or the earth has. But from here on, mass and weight, we're going to treat as the same. So if I talk about kilograms, think weight, even though it isn't really. It's really newtons, but don't tell anyone. And for weight, we use pounds. The mass equivalent, just in case you're interested, would be in slugs. Yes, that's right, slugs. But we're going to talk about weight in terms of pounds and in terms of kilograms, even though they aren't exactly the same, but it makes things simpler. So here are the units of weight in the English system. They aren't necessarily the only ones, but 16 ounces gives you a pound. 1,000 pounds, you've got a ton. Very simple. 16, 2,000, you probably already know these. For the metric system, it's a little bit more interesting, or easier actually. Oops, actually, I need to get rid of that. Sorry. Here we go. There. All right. So what we're talking about here is grams. That's the basic unit of, we're going to say, weight. Larger weights in terms of 10 times as much, decagram. 10 times that, hectogram. 1,000 times a gram, a kilogram. Going smaller, 1/10 of a gram is a decigram, 1/100th of a gram is a centigram, and a milligram is 1,000th of a gram. You've seen part of this before. It goes by tens. That's why the metric system is preferred by a lot of places, especially in the scientific community. Now, how do we change them? Well, if you followed me before, here's 950 milligrams, and we want to go to grams. So here's my way of doing it, and you can choose whichever way you like to follow. Going from milligrams to grams. The larger one is right there. So the larger one is going to have a smaller number, and the smaller one is going to have a larger number. If you keep that in mind, that'll help you a lot. Now, 950 milligrams. A milli means 1,000th. So, one way of doing this is 950 milligrams. Again, we'll use the unit, and we want to get rid of the milligrams. So we'll put milligrams on the bottom. We want to end up with grams, so that'll go on top. Which one is larger? Well, 1 gram is larger than 1,000 milligrams. and then all you have to do is run your calculator on it, and you've got 0.950 grams. Notice the milligrams cancel out. You're left with the grams for a unit. It's like that. You can also go by this small design here, which tells you to go from milligrams to grams. You're going to go 1, 2, 3 places. Since we're going to something larger, we're going to end up with a number out front that's smaller. They sort of compensate with each other. Now here are some equivalents that you might want to write on another card, or maybe you want to put them all together so you can see it in one place. Here's another one. We want to see how much 0.25 cubic grams are. So 0.25 cubic meters. How much does that weigh? What we're going to do is we're going to take that 0.25 grams. The equivalent is, since we want to cancel out the cubic meters, we'll put that on the bottom. What's it equivalent to? We want to get kilograms, so we put its equivalent up here, do the multiplication or division, and there's our answer. 250 kilograms is the same as 0.25 cubic meters. Remember, the unit fraction will get you a long ways. Now, if you want to convert English to metric or metric to English, here are some equivalents. So we want 160 pounds to kilograms. So we'll start with 160 pounds. Let's try that again. 160 pounds. We want it to kilograms. So we're going to multiply that by a unit fraction. We want to get rid of the pounds, so we'll put that on the bottom, so it's going to cancel out. We want kilograms on the top. 1 kilogram equals 2.2 pounds. So put your calculator to work, and notice the pounds are going to cancel out. We'll end up with kilograms, and there we've got it. 72 kilograms. Next, just some information for you. You might want to keep these in mind. If you ever traveled to a country, and most of the countries in the world have the metric system, you might want to know them. Most likely you already know the water freezes at 32 degrees Fahrenheit, boils at 212 degrees Fahrenheit, but you might not be as familiar with the Celsius ones. Well, imagine this. If you can memorize 32 degrees and 212 degrees, you certainly can memorize 0 degrees and 100 degrees. It doesn't get much easier when you're working with Celsius. If you want to change from Celsius to Fahrenheit, this is the formula I stick with. Although you can use this version of it, it's really the same thing, because 9 over 5 is the same as 1.8. So here's the one to know, to write down somewhere. If you want to go from Fahrenheit to Celsius, there's our formula. So let's see what we've got here. So the bills from your European vacation. I'm not sure what that means exactly, but your temperature is reading 37 degrees Celsius. Is that a good thing or is that a bad thing? So we'll take that 37 degrees Celsius. We want the Fahrenheit. So to get Fahrenheit, we'll use this formula right here, 9/5 C plus 32. 9/5 C plus 32, and that will give us our Fahrenheit temperature. So F equals 9/5, and we've got 37 for our Celsius temperature and plus 32. So you just put the 37 in for your Celsius temperature. Get your calculator to work. Oops, you don't need this. Let me write that again. Fahrenheit equals 9/5 times the Celsius temperature plus 32. 9/5. There's our 37 degrees. You might want to make that 37 over 1 plus 32. And what do we get? Are we sick or not? Well, here we are. The Fahrenheit temperature is 98.6 degrees. So 98.6 degrees Fahrenheit. Perfectly normal. Okay. No need to go to the doctor. How about the other direction? Here's your formula. All we need to do is take that 77 degrees and put it in where the F is. Let's go up here. C, Celsius temperature equals 5/9 Fahrenheit, which is 77 in this case, minus the 32, and that, if we hit our calculator, we get 25 degrees Celsius. Is pretty comfortable if you like 77 degrees Fahrenheit. Now, to wrap up things, there's also a third temperature scale. Actually, there's more than that, but the only ones we care about. Kelvin. 0 Kelvin is the same as negative 273.15 degrees Celsius. That's also called absolute zero. In other words, you can't get lower than 0 degrees Kelvin or the negative 273.15 Celsius. If you're using Kelvin, just add the 273.15 and you get the Kelvin version of the boiling point of water. Here are the formulas. If you want a Kelvin temperature from Celsius, use this one. If you need a Celsius temperature from Kelvin, there's your formula. As easy as that. This is something you could add to your storehouse of information. This shows you how they all compare. If you go up here to boiling point of water, that is, under standard pressure, 212 for Fahrenheit, 100 Celsius, really nice and even. And if it's Kelvin, it's not quite so nice, but it is 373.15 Kelvin, degrees Kelvin. And you see the freezing point, 32 Fahrenheit, 0 Celsius, 273.15 Kelvin. Remember, 0 Kelvin is absolute zero. You can't get any colder than that. So the Kelvin temperature, absolute zero. There's your Celsius temperature. There's your Fahrenheit equivalent. And that's your absolute zero. You're not getting any colder than that, no matter where you go. Well, folks, that's it. It's pretty short and sweet. See you in class. Bring your questions. I'll get you your answers. All right? Make sure you keep a sheet of all those equivalents and formulas. You'll be able to use them in a quiz or a test. Keep them with you. I don't expect you to memorize everything here, but I do expect you to know how to do things with that information. I'll see you in class. Bye-bye.